Sometimes we just give you the answer. Now for those that we only give you the answer without showing you step-by-step calculation, you got to do it after class on your own, making sure that you check the answer and you get the correct answer. Okay? And this is one of the homework problems, and I hope that when we finish today, you will finish the homework, the questions assigned in chapter 1. Okay? We have more examples. This is the quintessential example of dimensional analysis, and involves multiple steps, and even a little bit more complicated than this. Okay? Here you have a piece of gold, 1.2 ounce, and you pound it into a square rectangular sheet, a gold sheet, with an area of 400 square foot. The density of gold is given 19.3 grams per cubic centimeter. What is the thickness of the foil in centimeter, given all these conversion factors there? So again, in this particular question there, and you can see density is given 19.3 grams. Okay? Mass is given 1.2 ounce. Volume is not given. So based on this definition, density given, mass given, we can figure out the volume. The volume of a rectangular shaped gold foil equals to the area times the thickness. Thickness is the unknown. That's what we're trying to figure out. So when you analyze the information given here, you will be able to come up with a strategy. When you have a strategy, you will be able to come up with the roadmap, and with that roadmap, you will be able to find the answer. So in this case, again, using the definition of density, we can figure out the volume. Okay? So rearranging the equation there, volume equals to mass over density. And volume equals to area times thickness for the rectangular shape. Of course, it depends on the shape of the object there. In this case, it's rectangular. So area times thickness equals to mass over density. Thickness is the unknown. So basically, if you multiply 1 over area on both sides, you cancel out the area, and okay. So thickness equals to the mass divided by density divided by area. So here we have mass, density times area. So that's basically the information we're given there. We're given the density there, and we know from the density there we can figure out the volume. And based on the volume of the rectangular shaped foil equals to area times thickness. Area is given, mass is given, density is given, thickness is only unknown. So what we can do here is that thickness equals to 1.2 ounce, 19.303 gram per cubic centimeter, 400 square foot. Can we plug in the number like that to get the answer? When you do dimensional analysis, unit has to be able to cancel out. Ounce is not going to cancel out with gram. Square foot is not going to cancel out with cubic centimeter. So you have to do multiple steps of dimensional analysis. First, we have to convert mass into gram. Mass into gram, ounce to gram. 1 ounce equals to 28.35 gram. So 1.2 times 1 ounce equivalent to 28.35 gram. That will give you 34.02 gram. Why do I have these 2 digits in color? Well, because if this is the end of the calculation, you're supposed to keep 2 sig bit. 1.2, 2 sig bit. Okay? But we're not at the end of the calculation yet. So we keep a couple extra decimal places when we're doing the calculation. So mass is being converted into gram in this step. Okay? And then we calculate the area. Area is given in square foot. we got to convert it into square centimeter so that square centimeter can cancel with the cubic centimeter, leaving you with centimeter. Okay, so in this case, we convert the area from 400 square foot to 3.716 times 10 to the 5th centimeter squared. How do you do this now? Well, since we cannot plug in the number directly into the equation there, we have to do the conversion one step at a time. 1.2 ounce okay. 34.02 gram. That's the first step. 400 square foot. Well, we got to convert foot into centimeter. Well, foot has to be converted into inches first, an inch to the centimeter. So we know that each foot is 12 inches. Can we use this conversion factor directly here? Or do we have to do something else? Well, it's a square foot here. So we have to square this whole thing. So 1 to the second power is still 1. 12 to the second power is 144. So this conversion factor, given 1 foot equals to 12 inch, the secondary conversion factor would actually be 1 square foot, 144 inch squared. Now we need to convert the inch squared to centimeter squared. 1 inch, 2.54 centimeter. And we use that directly here, or we need to do something else. Square inch here, inch here. Well, we got to square it. So that will give you the answer 3.716 times 10 to the 5th centimeter squared. Now that you have the centimeter squared for the area times the thickness equals to the volume. Volume equals to density divided by mass divided by volume equals to mass divided by density. I'm doing a rearrangement there, and you can figure out the thickness there. And finishing the calculation, the thickness is going to be 4.7 times 10 to the negative 6 centimeter. Multiple steps. Okay, so what we have talked about today, dimensional analysis. We are doing a lot of calculation. One of the fundamental things I want you to remember, your takeaway is, always identify the conversion factor first. And sometimes the conversion factor is directly given to you. Sometimes you have to figure it out, okay, based on the given quantity there. So what we are talking about here, when you do problem solving and chemical arithmetic, the problem solving in chemistry requires what we call critical thinking skill. The questions are, most of the questions will go beyond the basic knowledge there. We're not going to ask who's buried the question. Grant is there. Well, Grant may not be there, but I'm just saying there. Okay. So we are giving you these examples there. And we can ask you how many